Use calculus to show that there is only one stationary point on the curve given here, and determine its exact coordinates and its nature. So we have a quotient where u is e to the x and v is x. du dx is e to the x. dv dx is equal to 1. So we go this way first. dy dx is going to be x e to the x, take away, go this way, and that is e to the x, divided by x squared. And here I'm going to factorize. It's e to the x, x minus 1 over x squared. If dy dx is equal to 0, that means that e to the x, x minus 1, over x squared equals 0. For a fraction to be 0, only the numerator needs to be 0. In fact, we've got a problem if the denominator is 0 at the same point. So, e to the x, x minus 1 equals 0. Now, one of the things you should know about e to the x is that it cannot be 0. It's never ever equal to 0. Think about the exponential graph. Any exponential graph you've ever seen goes like this. And the x-axis is an asymptote, so it never reaches 0. So e to the x can't be 0. The only thing that can make this 0 is that x is equal to 1. So if x is equal to 1, y would be e to the 1 over 1, since x is 1, which is just e. So we know the coordinates are 1, e. But we want to know the nature of the turning point. So we could use a second derivative test, or we could use a sine table. I'm going to go for a sine table here because I don't really want to differentiate this thing again. So, x dy dx. Remember, we can just do this as a number line as well. We've looked at that. And so we know that this is at 1. We can't actually use the value 0 because of the x on the bottom. So we'll think about what it is at 0.5, and we can think about what happens at 2. We know, of course, dy dx is 0 here. So if x is 0.5, this part would be negative. But that's squared, so it's positive. E to the x is always positive, so overall it's negative. If we put 2 in there, then this bit becomes positive. That's always positive, that's always positive, so it's positive. So down, across, up, and that means that we have a local minimum. Graph it on your class pad and see if you can find it.